Hi everyone, welcome back. So in this session, we are going to be discussing about the difference between the format specifiers percentage %d and percentage %i. So first thing what we should be knowing is both of these format specifier percentage %d as well as percentage %i is used on our int data type, or rather to say integer values, that is whole numbers. Right, so now we already know that printf function and the scanf function is what we call as formatted functions. That is, both of these functions make use of format specifiers in order to read the value also, and also to display or to write the value also. So when I am going to make use of percentage %d or percentage %i inside of the printf function, it is not going to show any difference. It is going to produce the same output. Okay, it is going to behave in the similar manner or the same manner. That is, it is going to print the variable's value in form of a decimal format. That is, in form of a decimal number, as a decimal number. So that is how the value is going to get printed. That is when I'm going to make use of it inside of the printf function. Okay, now, so then what is the difference? The difference is seen in the scanf function. So the difference between these two format specifier can be clearly seen when making use of them inside of a scanf function. Okay, now before going into the differences, first let us get to understand one small point regarding our integer data type. So we know that integer, or rather to say whole numbers, right? Our whole numbers can be represented. Okay, our whole numbers can be represented in our C language using three number systems. Okay, three number system formats are accepted to store or hold our integer values. That is, most frequently used is our decimal number system, and this is also the default. This is also what we call as the default number system. Okay, so decimal numbers, that is what we have been giving so far in all of our programs. When I am saying some examples like this, I am creating int a is equal to 10. So I'm saying int b is equal to some value like this. So all these are nothing but decimal numbers, that is base 10. So a combination of numbers between 0 to 9. That is what we call as a decimal number, and this is the default number system. So whenever we create variables like this is what we are giving. But other than the decimal format, we can also give the value for an integer variable in form of octal also, or in form of hexadecimal also. So now considering our octal, octal is what we call as base 8. So base 8 means a combination of numbers between 0 to 7. So remember, if you want to give the number as an octal number, then we have a prefix. We have a prefix. That is, we have to prefix the number with 0. That is, when I'm going to create a variable like this, I'm saying int a is equal to 0, 1, 2. You have to give the value like this. Now, this 0, 1, 2, whenever it sees a 0 as a starting value, the compiler will know this is not a decimal number, but rather this is an octal number. So when it is going to store the value of a, what it is going to do? It is going to convert this octal format into a decimal, and then it is going to store the value. So like that only it is going to maintain it internally. Okay, same way for hexadecimal. Hexadecimal is base 16. Again, I have to prefix it. Okay, I have to use a prefix for this also. So what is the prefix for an hexadecimal value? Okay, if I want to give an integer data type as a hexadecimal value, what is the prefix? 0x. 0x is the prefix I will give. So I will create the variable like this. A is equal to 0x, say some value. Like this I can give. Now, why is this prefix very important? Please understand that also. Now, if I am going to give without the prefix, imagine I am giving a number of an octal without the prefix. I am thinking, okay, compiler, take this as octal. But how will my compiler know? This is 12. 12 is a valid decimal number also, because combination of 0 to 9. So this is a valid decimal number also. This is a valid octal number also. This is a valid hexadecimal number also, because hexadecimal number also combination of 0 to 9. So this number is valid in all the number systems. So then how will my compiler know in which number system it has to take it? So that is the reason why we are giving the prefix. Okay, so this is how my integer is always represented. By default, as I told you, 99% of the program, we always use the decimal format only. But other than decimal, I can also use as an octal number system, and I can also use it as a hexadecimal number system. All are integers. All are of the data type int only. Right. So now coming back to our differences. Okay, now you know integer, what it is. Coming back to our differences. The main difference between percentage D and percentage I. Percentage D is for decimals. It can accept only decimal values. Okay, while see, I already told you the difference is in the scanf function. When you are using in printf, it both behaves in the same manner. So we are not talking about that. We are talking about the scanf. That is when I am going to read the value and store it inside of a variable. Right. So percentage D always can accept the value in only decimal system. It can accept only in decimal. If I am giving the value as octal or hexadecimal, it is not able to take it. It will not be able to read the value. But percentage I deducts the base. What do you mean by deducts the base? It will check, okay, what is the given prefix? Does it have any prefix or not? So according to that, it will detect, okay, if the prefix is 0, yes, this is an octal number. If the prefix is 0, yes, it is a hexadecimal number. If there is no prefix, then yes, it is a decimal number. Like that, percentage I, when I'm using in the scanf, it has the capacity to detect the base and then store the value accordingly. So that is the primary difference between percentage D and percentage I format specifiers. One of the very, very important differences asked even in interviews also, and also helpful for us in our programs. Right, so let us see an example to understand this little better. Okay, take a look at this. Here in this program, I have declared 3 variables. A, B, and C are my 3 variables. And I am asking the user to enter the value in a decimal also, in a hexadecimal also, in an octal also. Right. I am taking the value in all the 3 number systems. And each and every variable is going to hold that value. But look at the format specifier I am making use of in the scanf function. I am using percentage I. I'm not using percentage D. I am using percentage I. Why? Because I want the value to be taken according to the number system given by the user. So that is why I am using percentage I. Now, in the printf also, see what I have done. I have used only percentage I in the printf also. Okay, but I told you, in the printf, whether you are using percentage I or percentage D, it doesn't make any difference because the value will always be getting printed in the decimal format only. Okay, if you want the value to be printed in an octal or in a hexadecimal, we have other format specifiers for that. Okay, you remember we have already covered that in the printf function. When we are discussing about the printf function, we discussed about those also. Here, we are just going to say about percentage I. So when I'm going to print using percentage I, it is just going to print the decimal equivalent of the values. Right. So let us try to execute the program also. So have a look at the same program I have done here. So what I have done, I'm saying enter a decimal number, percentage I, store it inside A. Enter an octal number, percentage I, store it inside B. Then hexadecimal number, percentage I, store it inside C. So all the 3 variables are stored inside. Then I am printing the values. Now let us run this program. Okay, so when I execute the program, see what is it? Enter a decimal number. For a decimal number, no prefix is needed. Directly give the values. Enter. Now, enter an octal number. So what did I say? 0. So 0, I am giving 12. 0, 1, 2. This is the number I am giving. Then see here, enter a hexadecimal number. So prefix 0x, then I am giving A. Now see, when I run the program, 89 as it is, no need of any conversion. It is already in a decimal number. So decimal number is getting printed. Now you see what happens here. I have given the value as 0, 1, 2. That is, I have given the 12 in an octal format. So when it is getting printed, see what is happening. This octal number is getting converted into a decimal equivalent and then it is getting printed for us. Same way, yeah. So I told you, right, in a hexadecimal, what happens 0 to 9, then valid numbers are A to F. So A to F can be in capital letters or A to F can be in small letters. So what happens? A represents 10, B represents 11. Like this, it is going to keep on going. So that is what is coming here. So I am giving 0x A. A is the value for 10. So that is the value you are going to be getting printed. So understand, percentage I gives us the flexibility. You can give the integer value in any of the number system formats. So whatever you are giving, it will be able to accept the values. Now you see, instead of I am using D, percentage D. Here also I am using percentage D. Here also I am using percentage D. Okay, for printing also let us use D itself. So I'm not changing anything else in the program, just the format specifier. I have changed from percentage I have just changed it to percentage D. Now I'm going to run the program. So decimal number, let us give the same value. No problem, successfully taken because percentage D is going to treat the value as a decimal only. Now, you see I'm giving here as an octal number. Okay, now give a hexadecimal. 0x, yeah. See what is the value you are getting. For decimal, it is reading perfectly, no problem. But for an octal value, see what it is saying. It is literally taking the number. See, whenever we are having a decimal value, when you put a 0 in the front, it has no meaning. So what we generally do, we omit the 0, we take the remaining of the number. That is what is happening here also. So this is not an octal value. This is a normal decimal value. Now come here, 0xa. It cannot read because it can read only decimal value. So it is not able to read this value at all. So it is skipping it. So what is the value stored inside C? Nothing. C is not having any value at all. So remember, according to the compiler in which you are running the program. Okay, some compilers may produce some garbage value also for the C variable. Some compilers will give the value as 0. So it is a compiler dependent output you will be getting for C. Because C value is not read at all. C is empty. That variable is not having any value at all. It is empty. So according to the system in which you are running, the output of the C variable will differ. Either 0 or some garbage value will be displayed for us. But see how the percentage D is working and the difference between percentage I. So this is very, very important for us to understand how the working of it is going to be done. Right. Okay, guys. See you in the next video.